All right. Oh, Erik is muted. There he is.
But I have to agree somehow
Yeah.
that okay, it's recording.
Nice.
All
All
right.
right.
Welcome everybody to episode number 5 of our podcast, Error Correcting Erik, where we read through the book of David Deutsch, The Beginning of Infinity, together. And every episode we discuss what we've learned in the chapters. As usual, we have me, Erik, who's reading chapter by chapter, and we have our seasoned veteran Thomas, who will shed enlightenment on what we've learned. So in this chapter, it's called
Indeed.
Reality of Abstractions. And the main first topic that I've learned from that there's basically two things in reality. We have our physical reality, everything that makes up the universe, atoms and energy and planets and galaxies and so on, black holes and all the other things included. And then we have abstractions, which it also exists in reality, but they don't have a material form. And it is ideas. It is, we can discuss, you just went on a trip on Mexico. We can discuss your trip to Mexico, how it went. You can draw a plan of your trip. You can dot on a map where you've been. All of these things are abstractions. And usually what we do is when we discuss reality, we talk about it in abstractions, in different types of abstractions that are easy to understand and that are easy to share. So that's one of the first big things that I picked up from this chapter.
Absolutely. And I think, it goes beyond even just, I mean, there's always like shorthands that are easy to use in terms of explaining what abstractions are, but it's really important, I think, to note is that we only react with reality through abstractions.
Mm-hmm.
Um, even our I think we once had a discussion about your cat, right? And how that even your cat is an abstraction, as a concept, right? So we symbols, right, are also abstractions. Language is an abstraction. Even concepts like the laws of physics are abstractions
Mm-hmm.
themselves, as well as let's say your mind, right? The brain is an abstraction. So I think that's also something that for me um, took some time maybe to kind of really grasp, because you know although these concepts maybe on face of it seem simple enough, um, often, and I think the proof is in the pudding, which means that if you can explain the concepts in different words, it often shows a level of understanding, rather than just parroting, kind of what you read or heard, as well. So Erik did introduce me here as the seasoned veteran, but I am
Yeah.
still very much a student as well. I think I've just I'm as far as away from the beginning of infinity as you are. So we are both always infinitely far away from it. But I think maybe I can help indeed, maybe clarify some of the concepts through my journey. So I did want to just maybe add for the listeners that we'll be in time adding an errata list to the podcast, so that anything that we say that is wrong, or with error, obviously, because everything is error prone, we'll try and clarify that as much as possible. But it is possible, of course, that things I say or we say here during the thing aren't exactly maybe what was intended or in the book, or maybe examples that I know I once used the example of, and I don't want to get too long into this, but for example, I used the example of the bending of light, as the was it no the planet orbiting but potentially Mercury as a refutation of Newtonian physics, but actually it had to do with an experiment which had to do with the bending of the light of the sun during a solar eclipse. So anyway, it still kind of refutes it, but it's not what actually happened in terms of the actual refutation. So anyway, um, look out for that, and thanks obviously to anybody listening that sits through those errors. We'll do our best to correct those.
Yeah. And on that note, I actually prepared a very first errata. in this show. And it's about penguins, because last time we had a discussion on evolution and on Darwinism, and we discussed, did penguins evolve from a flying bird species, and did they lose their ability of flight, or did they evolve from a species that never was able to fly? So I looked that up, and according to National Geographic, penguins actually evolved from a common bird answer, which branched into penguins, albatross, and birds like pelicans. So there was a common ancestor that had the ability of flight, but at some points, penguins also evolved to dive and to swim, and it became more efficient for them to swim and to dive. Thus, they slowly lost their ability to fly. So it's an interesting insight, I thought, that penguins actually were able to fly in the past in some other form, and they lost that ability.
Wow. Yeah, that was, I think, one of the open-ended questions where we left
Yeah,
off last time, right? As well. Yeah. Well, that's cool. Thanks for
exactly.
sharing that. Yeah.
Yeah, cool. So we will put the link to the article, to the National Geographic article, in the description and in the show notes. So when we continue in the chapter, the reality of abstractions, not only have we discussed what abstractions are, but also how we interact with it. And there's a beautiful example of, I believe it's something that we discussed in an earlier episode, of the copper statue of Winston Churchill, which is actually part from his different book, The Fabric of Reality. But since it is such a profound insight, it is repeated in this chapter.
Mhm.
And it's basically about that different levels of explanation are equally valid. And
Mhm.
that there is no true or real or final explanation. Thus, there's no true or final abstraction of something that you want to describe. Um, we have some other examples that we can discuss later on, but maybe you can elaborate a bit on the Winston Churchill example.
Yeah, and I think that also has to do more, with the emergence phenomenon that exists within abstractions. And easy examples are, for example, if you want to calculate, let's say, the behavior of water at boiling point, for example, like you don't need to go into, the reductionist view of separately calculating every water molecule's behavior to then aggregate that into, the final behavior of that body of water, right? So we do use different, because it would be, I think, it will be not computationally efficient to do that, first of all.
Yeah.
But it's also not necessary, because there is an emergent level phenomenon explanation that we have that we can actually use, back of the envelope kind of calculation. So the example goes as follows, right? There's a copper atom on the nose of Churchill, on the statue, sorry, of the nose of Churchill, not the actual uh, prime minister, ex-prime minister. And the thought experiment goes as follows: is like, how do you explain the copper atom of the nose of the statue of Churchill being there? And there's one approach you could go, and it's like explaining it from a molecular almost perspective, a reductionist perspective, where you say, well, there was the Big Bang, and then gases emerged, and galaxies came out, and the universe cooled down, and then stars were formed, and that made different chemical compounds come to existence, yada yada yada. And then just kind of like knocking the billiard balls, and all of a sudden, there it is, that one copper atom on the nose of the statue of Winston Churchill. Now, you're not necessarily wrong in saying that's what happened. It's just, it doesn't explain the phenomenon of the atom copper on that statue's nose. It describes more of the pathway, if you will, even that it took to get there, but it doesn't invoke anything else. So you need another, what I think they call level, as you said, levels of explanation. And so the right kind of answer here is that we fought a war, World War II. Winston Churchill was a very important political figure in the battle against the Nazis, and making sure that the Allied forces won that war, and that ideological war as well. And in the culture of Great Britain, statues and across most of Western, I think, societies, statues are put forth about important people in history to honor them, you know, in that society. So you need, you know, you need culture, right, to explain why that copper atom is there. You need the World War II, and also you need to know that, you know, copper is used in metals to create said statues. So um, which is also part of the explanation. So it has kind of, you know, those hard to vary components, being, you know, British culture, being the fact that copper atoms are used for the setting up of those statues, and also invokes, you know, important people that we do that for in our society. So that is more of an explanation of why that copper atom is there. It's just not in the sense of a kind of a, what we say, maybe a technically scientific explanation, if you will.
Yeah.
It's from an emergent phenomenon such as, you know, social behavior and so forth.
Yeah, and this reminds me a bit. On YouTube, you can find these series where they explain complicated concepts such as cryptocurrency or black holes to like a 5-year-old, and then to a 12-year-old, and then to an 18-year-old, and then to like you know, a college student. And they go through these different level of explanations, all of them being equally correct. And usually they start a bit more at the abstract level, let's say cryptocurrencies. When you look at that specific episode, they start explaining about, oh, you can trade with anybody in the world without having to go through stuff. And that's like the first level of explanation of what cryptocurrency is. And then they go all the way up to the college student who I believe is studying mathematics or computer science, and they talk about the actual blockchain technology and how it works. So it really reminds me of those different types of explanations.
I see what you're saying, and as you were saying that, I was trying to actually. My first idea was to not necessarily disagree entirely with that comparison, but more to maybe challenge it a bit, because I think if you would have to explain, you know, blockchain or crypto, um, all of those components are required. I think it has more to do with the level of understanding of the mind
Yeah,
that's trying to comprehend it. I don't think it speaks to the actual explanation of why blockchain exists. I think you're speaking about different aspects of it that together form the explanation.
yeah, I see. Yeah,
Um, you know what I mean? Like, you know, if you want to get into the mathematics of, you know, blockchain and the computational things, then, you know, do you really, like, you need to kind of have an understanding of what computation is and what, you know, the internet is and those things. So you need those aspects of it. But I don't think you necessarily need to explain computation as a you know, let's say as an actual endeavor to have somebody understand what cryptocurrency is, if that makes sense.
yeah, I see. Maybe there's another difference in those two, you know, the copper statue story and then the cryptocurrency explained on different levels story, where with the copper statue, there's a clear distinction between like the scientific explanation about atoms and how they came to be, and like, let's call it the social cultural level of explanation.
Yeah, yes, but also that is a bit of a misnomer, because you it's not that it's a different field of explanation. It is that
Mhm.
it's a completely different level of
Yeah,
explanation.
yeah, I see.
You still need to know what a copper atom is and what a molecule is to fully provide an explanation for that copper atom being there. But it's that the reductionist view doesn't get you to an explanatory framework of why the copper atom is there. It just says, you know, it's like they call it like an all-purpose explanation, where you say, well, you know, this is the behavior of molecules, therefore that's what they do.
Hmm.
It doesn't explain the actual phenomenon you're trying to describe. It just says, you know, we live in this universe and that's what happens in this universe. It doesn't explain a specific thing. It explains everything, and therefore it
Yeah,
really
I
doesn't
see.
do anything at all. Um, if that makes sense. So it's not that it's a different field, and you're invoking, because you need to have, like, sociology is not, it's not a different type of knowledge than, say, molecular knowledge. It's both knowledge. It just doesn't, it takes those parts together to add to the context of explaining something about the physical presence. and the reasons, right? The explanations of that thing. Just saying, atoms do stuff,
Yeah,
is, even if you confine it to the weak force, the strong force, and gravitational pull, and even if you invoke all of, let's say, the constraints that the universe has for that atom, you've still not explained, why that one there, right? Um,
exactly. Yeah.
yeah,
Or why the entire copper atoms are in that particular configuration that symbolizes a person. You don't explain any of that.
right.
Yeah,
Also, yeah,
yeah.
absolutely.
There is actually a second thought experiment in that chapter, and it's called the domino computer machine. Let's call it like that.
Yeah.
So I'm going to try to explain it as briefly as possible. How a computer works on a basic level. It's a bunch of zeros and ones, yes and no's, and you can configure them in different ways, such as a NOT gate or an OR gate. We're not going to go too much into depth right now, but you can actually simulate that with dominoes. You can align a bunch of dominoes, and let's say that when a domino is standing up, it's a one. When it falls down, it's a zero. And you can split those, you can add them back together. So you can make all sorts of complicated configurations, and you can actually build a computer that does basic calculations with domino bricks. It would take a long
Hmm.
time, but you could actually do that.
Yeah.
And in a thought experiment of this chapter, they have a system of domino blocks that can jump back up. There's some kind of spring loaded, and they configure it in such a way that it can calculate if a certain number is a prime number or not. So somehow you can configure the input dominoes to represent a number. Let's call it 17, number 17. You hit the first domino, a lot of things starts to fall over and starts to do things. And then at the end, a single domino brick will either fall over or it will not. And that will be the answer, yes or no. So that's a setup of the thought experiment. And then there's an external observer who has no clue about dominoes and computers and prime numbers, what's actually going on. He just sees the dominoes and he asks, why did the domino, the last one, fall over? So, and there are multiple answers who are all equally valid. So you might say, oh, because the domino before that didn't fall over, which is true, but that doesn't explain a lot. It doesn't explain the entire phenomena. But you could also explain, oh, because it did fall over because 17 is a prime number,
Hmm.
which is also true, but it's a completely different level of explanation. And both are equally right.
Yeah. Is it not on and off rather than yes and no, by the way? Just uh,
Yeah, could
yeah.
be.
But a switch is on or off,
Yeah.
and then that constitutes a one or a zero. But no, that to me also was. It took me a long time to really kind of make sense, because it's quite it's written out technically a little bit in the book, I
Hmm.
feel.
Yeah.
So but at the end of the day, it's quite a simple concept. It's like, let's say you have a computer which operates through the modes of dominoes, which is, again, like, it is possible technically, because all you need is like you said, those switches, and then you can kind of create a computer, and that's really all you need to create any computer. Because it's a universal. It's a computationally universal. Computation is universal, basically. So it would be, again, computationally inefficient to do that, right? Because you would it would take a long time, and just I think the maintenance of that machine would
Yeah.
take so, like, physically so long. But again, it's a thought experiment. So, but yeah, at the end of the day, there's, again, similar to the copper atom analogy, is that there's the reductionist view of things, kind of, or the causal view, let's say, where you just explain what happened based on what previously happened, and then what previously happened, and then what previously happened. But you're never really explaining the thing itself. You're just it is a
Hmm.
sequence of events that you just invoke as a kind of a cascade of things, without really addressing the reasoning of why, in this case, that tile with that's at a prime number fell over. And that's the thing. If you would, as you say, like, as an external observer, you would view that, those dominoes going over, and there's a reason why it's typically, again, the prime numbers that fall over, because that is how it was programmed to happen, right? So any other explanation, although again not wrong necessarily, it just doesn't explain why that's right. It doesn't do that. It says maybe why that because of a reason of the previous event, but mind that explanation is always it's always fuller, right? Almost it's almost it simplifies things. It's overarching to the phenomenon that you see. It because if you would only purport to explain a phenomenon based on the previous phenomenon, then you're not explaining it. Then does that make sense?
Yeah,
Then you're yeah. So
it does. Yeah.
yeah.
It. I'm gonna jump to the summary. If there are other things
Uh-huh.
that we want to talk about, we can do it. Because I think I understand the general concept, but I will read out the summary because there's some things that are not fully clear to me yet, and maybe you can shed some light on it. So
Okay.
on the last page of the chapter, there is a very short summary. And this one it reads, reductionism and holism are both mistakes. In reality, explanations do not form a hierarchy, with the lowest level being the most fundamental. Rather, explanations at any level of emergence can be fundamental. Abstract entities are real and can play a role in causing physical phenomena. Causation in itself, such an abstraction. Causation is itself such an abstraction.
Yeah.
So there are some parts that I do understand. Explanations do not form a hierarchy with the lowest and most fundamental. Uh, Multiple explanations can be wrong. Uh, but then
Yeah.
he says reductionism and holism are both mistakes.
Yeah.
Maybe you can shed some light on that point.
Sure. So there's no such thing as a foundation, right? That's I think the first thing, because you would have to ask why that foundation and not why
Mhm.
another. Um, so reducing everything to, let's say, atoms, again, like you would still have to explain why an atom, in a sense, and just then going further reductionistic, if you will, doesn't solve anything. It just tries to, but the thing is, it's been so successful in science. The reductionist approach to scientific research has been so successful that it's almost been taken as for granted as being the way that we're going to uncover everything. It's always like,
Mhm.
we go for the quark, and then string theory, right, is trying to explain something within that quark. And it's like once we find the smallest of the thing, then finally somehow we'll have that theory of everything, almost, if you will. But it's a foundational misconception, because then why that foundation and not why another? It doesn't explain it. It just kicks it down the line, if you will. And holism is the same. Holism says that there's some kind of main thing going on, like this holistic view to something, where you have to like a lot of sciences, from like medicine, try to like have this holistic understanding of the body, and acupuncture together with all these other things, and like it's all a combination of things rather than that in itself. But mind you, that in itself is, again,
Mhm.
an argument that is one thing. So it, it it's just not possible. You can't get there. You whatever holism is purporting to solve, it's not doing it, because then why that and not another? So the mistakes go both ways, but
Yeah.
it's the same. I think the way I understand it's still the same mistake. It just doesn't get you anywhere closer to, again, having explanation of why a certain phenomena came to be, or is a thing. And I think the important thing with abstractions is that people should note that it's not just like imagining anything, and that makes it an abstraction, and therefore we have to take it seriously. Abstractions are real in the sense that they also obey certain laws, and they obey certain um, we don't. I think I'm not, maybe I'm a little bit out of my depth here in talking about this, but one of the best quotes I found was like Dr. Johnson's criteria for something that's real. Like, how do you know if something is real? And the answer would be if it kicks back. So
Yeah.
if you kick a rock, then it's an impulse from the foot to the brain, and the brain interprets that as pain, and then and then the rock is basically kicking you back, because otherwise the rock would be kicked forward, but because it stays stationary, how if you push the table, like it's actually the table pushing back at you, right? So similarly, it's like if abstractions, they also kick back. So you can't just mathematically invent whatever you want. There's certain realities to those abstractions, right? So if you divide something by something, then there's a that has an answer.
Yeah.
And mathematicians often, when they go into these abstract, let's say, endeavors, and searching for patterns or for explanations to certain things, then they can't just do what they want, right? The numbers are obey reality. Let's say the abstractions obey certain, I want to call it laws, but I'm not sure that they're called laws. But you can't just fidget around and make that mathematical proof happen just because you want it to. The mathematician has to kind of work with it, and uncover the objectiveness of that abstraction. And that's also something that, like, Deutsch explains as being something that kicks back, right? Because I think there must have been mathematicians that go, "Oh, I didn't expect that," right? Like,
Yeah.
from a proof or from a theorem. And one of the kind of the coolest ones there is like the prime twin pair theory, I believe, which hasn't been proved. But it basically, if you plot on a line all the prime numbers, you would find that they often, there's two that appear closely to each other.
Oh, yeah.
Maybe you can, while I'm explaining this, you can
Yeah.
look it up and share it. It's called the prime twin conjecture or something.
Yes. Twin prime conjecture. Okay, I got it.
And if you show that on the screen, so basically what happens is there's a lot of prime numbers that occur together, basically, and that's why they call it the twins.
Yeah.
But then there's a long sequence of numbers where they don't occur anymore, and then they pop up again, and they pop up again in twins, and kind of in pairs. Sorry. So that supposedly goes on forever, because it's an infinite sequence, right? So let's say the natural numbers. But I don't think it's been proven yet that goes on forever, and maybe it's not provable, because that's also what Gödel's theorem is about. Yeah, let's see.
So here we have 3 and 5, 5 and 7, 11 and 13, and so on and so on.
Yeah.
And then it goes, in this example, to 137, 139.
Yeah.
I was looking for like a beautiful image that would represent it, but didn't immediately find one.
Yeah, they should. I've seen a couple of those on other podcasts, I believe. But so yeah, the point being there is that must have an explanation, right? It's not randomly. So there's a reality to prime numbers, right? That are, let's say, not tied to just us thinking about them. So they're not just a conscience creation, if you will. There is an abstract reality, if you will, if you want to call it that, and it obeys also certain. Again, I don't know if they call laws or rules or something, but it's important to note that there is such a thing as an objective abstraction, almost.
Yeah.
Yeah.
If you do some research, you find these kind of images, these kinds of graphs. I'm not sure that those are the ones that you're referring to.
No, not specifically, but it was more like you could see them just pop up, and like you would see that at the number. But it's okay. I think people understand.
Yeah.
What we're going with this. So it's yeah. I think the kickback principle is kind of is a nice one, where that kind of dictates it being real, because you can't just mold it into whatever thing it is that to fit whatever subjective narrative you have, or to fit whatever subjective idea that you have about that thing. You have to deal with the reality of that abstraction, basically.
Yeah.
Um,
I think that looks back to the opening of this episode, where the basic insight from this chapter is there are two things in reality. You have the physical reality, planets and so on, and you have the reality of abstractions, which are
Yep.
equally real.
Exactly. And then if you go into things like Gödel's theorem, and for example, I don't know if you can look that up as well. Gödel's theorem, it has to do with the incompleteness of a set of numbers, and there's like two or something, like two criteria. Gödel's incompleteness theorem.
I haven't heard of
Gödel's, sorry.
Gödel before.
Gödel's, Godel.
Godel.
Yeah. So any formal system, it speaks about the completeness and the consistency of formal systems. And
Yeah.
once you go over, I believe it's like first order logic, no system is complete or necessarily consistent. So that means, and I'm probably butchering this right now, but that means that there are unprovable truths
Mm.
in that system, as well as wait, that's the only one I know for sure. So which means that there are certain things that system holds to be true in itself, right? So in the system itself, it is true, but you cannot prove it. So
Yeah, I have the Wikipedia definition here, so I'll try to read it. It says the first incompleteness theorem states that no consistent system of axioms whose theorems can be listed by an effective procedure, such as algorithm, is capable of proving all truths about the arithmetic and natural numbers. For
right,
any such consistent formal system, there will always be statements about natural numbers that are true, but that are unprovable within the system. I think that's what
exactly,
you're
yeah.
explaining.
And then you have also the decidability I'm reading as well. So you have the incompleteness, and then you have the
Yeah.
undecidability or the decidability. But just if we pause for a second to think back on that unprovable truths, that's interesting, right? I mean, it literally means that there are certain things that system says to be true that you could never prove, although they're true.
Yeah.
So I mean, just wrapping your head around that took me a while. It's like, because you have to understand a little bit what mathematical proofs look like, and I'm not by far an expert, but I remember back in school, and Erik and I, we went to school together in high school, and
Hmm.
a mathematical proof would be if you would arrive at a certain conclusion via a different, let's say, a different point of a framework, vis-a-vis that what you're trying to prove, then you would have proved it because you have proved it from a different angle than right from the angle of the equations themselves. You would maybe, I know that often like matrices are used, and stuff like that to prove from a, again, I'm probably butchering it right now again, but from a different angle, if you will, that you come to, to prove 1 + 1 is 2, for example. It's like 500 pages or something. um
Yeah, I've
but
seen that
yeah,
one. Yeah.
yeah,
Yeah, this reminds me of axioms. We've been to high school together, and we had to learn these proofs based on axioms. And there's a simple example here. An axiom from geometry is that you can extend a line to infinity.
right.
Apparently you cannot prove that, but it is true.
Well, I mean, no, you don't know if it's true because you can't prove it. That's the point.
Yeah. So you need to
um
assume it's true.
well, an axiom is by definition kind of
An
an
assumption.
assumption, right? But
Yeah, okay.
um which you build a system on, right? So that's the point. So based on, so the axiomatic realities of your system produces outcomes that are true yet unprovably true.
Yeah,
So
I
you can
see.
never know that those are true. You would have to again assume. But what Gödel's incompleteness theorem or undecidability kind of proves um, is that a formal system based on certain axiomatic principles produces results that are true yet unprovably so.
Yeah, I see.
So you could never say that they're true, in a
Yeah.
sense.
But you've proven that they exist, so they probably must
Yeah,
be true.
you
Yeah.
can prove they're out there. Well, you can prove that the system can produce that. That doesn't
Yeah.
necessarily prove that you have one of those in your hands, because you could never know, right?
Yeah, I see. Yeah. It's a funny one. Okay.
Yeah.
And I believe we've went to most of the stuff that we wanted to discuss in this chapter and the summary. Is there any other important burning issue that you still want to highlight?
No, I think it's, well, I mean, I say no and then I say something. So,
No,
so
but
yes, I think so. I think, as a last, maybe just from a personal perspective, I found it, it took me a while to grasp, let's say, that abstractions have realities to them. And I think, David Deutsch also says that he's a dualist. So,
Mhm.
there's a physical real world, if you will, which, what's out there, and then there's how we interact with it, which is through abstractions. And they also obey, again, rules, laws. I don't know, and maybe we should look up what that's called, what abstractions obey, but let's call them also realities. But we're, it's a bit, you get into these words, confusion, because if I say the reality of abstractions, then I don't mean actual physical reality, but
Mhm.
I mean the abstractions that we use to operate that fields. And mathematics is one of those examples. The fact that the language that we're using right now is an abstraction, right? As well. And even your your eyesight is creating abstractions, for you to see based on these problems it solves for you as a person, in a sense. So if I could tell myself, like, reading this again, all of this from the beginning, and help myself, and it's kind of what this is about, right? Is helping you also understand the concepts quicker and through conversation. And one of the main things I would tell myself is there's a difference between, again, the ontology of something and the epistemology of something. And I think that feeds to the same abstraction, physical reality. I think it's the same conversation, because if you look at what an ontology is, the ontology is the actual physical thing that we're talking about. Let's say, so if we're discussing your cat, right? Let's say whatever that cat is in reality, um, that's the ontology of the cat.
Yeah.
But if we are speaking about what we know about that cat, then that's our epistemology. And then we, either we understand biology and we know that's a living organism, or let's say we don't understand biology and we think it's a god, right? And we think it's like a special creature that comes out of nowhere, like, kind of. So depending on what our knowledge is of something, which hopefully increases over time, because we are interested in solving certain problems, then our the epistemology changes, right? Because
Mm.
let's say we understand more and more about that cat, if you will, but it will always still be that cat in reality. Um, that's the ontology part, and then the epistemology is our knowledge of the ontology, if you will. And I think that's the same for, let's say the epistemological cat is the abstraction, and the ontological cat is the actual, physical reality cat.
Yeah, I see. Yeah.
um, and to me, that if I could have just started kind of just understanding that decisiveness better, that it's our knowledge of something that changes. It's physical reality, obviously. I mean, unless there's, again, a reason for a supernova to explode, then that's a change in our universe, right? But it's not a random change. It's dictated by the laws of nature, which we can understand. So to close this off here is like, the next part here, that I would like to tell you, that I guess I would tell myself,
Mhm.
is that, the laws of physics as well are an abstraction.
Yeah.
Um, and you can prove that the laws of physics are computable. David Deutsch does this. He proves computability of the laws of physics. Therefore, we are universal explainers, and we can compute those things. So therefore, anything that is computable, anything in the universe is computable, is also knowable or understandable,
Mm-hmm.
if you will. And again, I'm probably butchering a little bit the proof here, but David Deutsch has a publicly available proof where I think he proves that the laws of physics are computable,
Oh, yeah.
which means that we can understand them. So the abstractions are a shorthand often in everyday language, and we kind of know what we mean by those things. But if you go into the philosophy of that, then I like talking about those things, because then you get more into hey, what's our episteme, which means knowledge, I believe, in Old Greek. Then you're
Mm-hmm.
talking about the epistemological, which is our knowledge of the thing, and that's where I really get interested. I think if that the duality there, so it's a dual philosophy of reality. I think if I could have just grasped that from the beginning, I think a lot of the concepts that came later would have come easier to me, if you will.
Yeah, I see. That's a cool personal insight. Yeah, thanks for sharing. So to close this episode off, I also have a personal thing that I would like to share, and it's about actually the journey, error correcting journey, and about the enjoyment of reading. So we've discussed last episode that I tend to cheat on David Deutsch. So in parallel, I'm also reading other books. And a book that I've read is, I have the Dutch version here with me, Children of Time, from Adrian Tchaikovsky. It's a science fiction book, and explanatory knowledge is an important part of it. And as I'm reading David Deutsch, I'm thinking about this story in a completely different way. This is kind of cool. So I'm at the point of reading the book, then I'm starting to see how the theory or the ideas, I recognize them in other works and in other parts. And I will quickly, without going too much into, because this is not a podcast about this book, it's about David Deutsch's book, quickly explain what Children of Time is about. So humans, they're far in the future. Earth has died out. And one of the things that they've done is they have created a artificial nanovirus that can rapidly accelerate the intelligence of other species. And they sent a bunch of monkeys, primates, to an Earth-like planet. They also sent the nanovirus to the Earth-like planet, and they hope that the monkeys, they will evolve intelligence over a rapid period of time, and then humans will come and they will worship, and then the monkeys will worship the humans as gods, and the humans can live as gods, and then the monkeys do everything. So that's one of the things that happens in the books.
Oh, wow.
But yeah, which seems like a very stupid idea to me in the first place, because there's a different science fiction story where they've done it. It's called Planet of the Apes. They made intelligent monkeys, and what happened? The monkeys got really mad and they killed all the humans and they took over the world. But anyhow, so what happens in this book is the experiment goes wrong. The monkeys they burn up in the atmosphere, but the virus lands on a planet and actually infests a bunch of spiders. And these spiders, they become intelligent. So in the book, you follow the development of society of spiders, going from simple animals to hunter-gatherers to their space age.
Uh-huh.
And what's cool is that as they rapidly evolve, what they call insight with a capital I is their most valuable resource. So they trade insight with each other. But what is insight? It is actually explanatory knowledge.
Yeah.
And it goes from very simple things like, oh, there is a dangerous predator hiding in that cave. They communicate that to different groups, and they exchange explanatory knowledge. And that's how they grow their society. And it's really interesting that that's such a fundamental part in this story.
Yeah. Yeah. That's
And
go ahead. Sorry.
no, go ahead.
Yeah. I mean, obviously, there's I'm not sure if it's a consistent let's say a simulation, because of the science fiction tends to like have inconsistencies in its own story because it needs to, like it's like movies that say, "Oh, the aliens did it," right? Or
Yeah, yeah,
whatever. But what I do like about that, what reminded me of, and I think I would wonder how the book explains how humans created that knowledge gun, if you will, or that
yeah,
intelligence, because like we've discussed in the past, intelligence is not a spectrum. It's a either you're computationally you're a universal explainer or you're not. There's no such thing as being half a universal explainer. It's
exactly.
a qualitatively different thing. So that would mean that that species would have to immediately switch into a universal explainer. So apart from the fact that maybe they have different evolutionary processes in this book attributed to those spiders, and obviously it's science fiction, but I think what David Deutsch often speaks about is like maybe not in terms of frustrations, but I could imagine somewhat being frustrated sometimes at lazy science fiction that just you know again does the aliens did it, or the kind of
Yeah,
these really absurd inconsistencies that don't jive within its own narrative of a properly consistent world, a simulated world, which basically science fiction is meant to be often, right? Like Star Wars and these things. um, but then what I liked about what you said is if indeed the trading of knowledge, and Naval, who's also a fan of David Deutsch, and he's like a tech millionaire or whatever, and he
hmm,
helps promotes the work of Deutsch as well. I'm subscribed to his newsletter, and in one of the newsletters he said if there would be an intergalactic species out there that is so advanced and evolved, then they would come to us. They would not want to trade natural resources, and that's what all the dooms prophecies of,
yeah,
of alien invasion, they always say, oh, they want our water, or they want they want to harvest us or something, and
yeah,
like because we have something so special that their earth has doesn't have anymore, or their planet, sorry, doesn't have anymore, and they've come to steal it from us. Well, if they're capable of interstellar travel, then they're quite capable, and they've probably solved, for example, a lot of society problems that we're still facing. For example, murdering each other, right?
yeah,
Or war and violence towards each other, and like they've probably solved most of those problems because they've been able to get to an interstellar part of their evolution, and they can traverse the galaxy. So I doubt that they would need anything from us apart from
exactly.
knowledge. They would want
Yeah,
to have more knowledge about things because they would understand that it is not a natural resource is not a natural resource in itself. It only becomes a natural resource if the right knowledge is applied to convert it into, say energy, right? A planet filled with fossil fuels doesn't make it, like automatically a planet where that's being exploited for the energy that one can get. It is only when the knowledge of understanding how to extract that and to turn that into, let's say, wind, sorry, not turbines moving that create
yeah, yeah,
electricity, that power an economy. It's only that knowledge that allows, quote unquote, a natural resource to be a natural resource. So often when like people, evolutionary biologists or historicists, they tend to see wars and conflicts also in the past as battles for natural resources. Um, but they say obviously, let's say society X won because they had metal and metal was used for weapons, and society, they were fighting society B that wasn't in a metal rich environment, and therefore, like like that doesn't explain still why society A had the knowledge to use that metal and create weapons out of it, and society B didn't, right? And I think that's what a lot of people get wrong is they misappropriate current knowledge to a society that didn't have knowledge back then. So these intergalactic and in your story, these spiders, apparently they have
yeah,
come to understand, um, rightfully so, it is about the insight then apparently, or the explanatory knowledge, because that is fundamental. Apply the right knowledge on the right thing, and literally everything that's not forbidden by the laws of physics or the laws of nature is possible. Um, so that's that reminded me of that Naval newsletter where he said if aliens would come, they wouldn't really want anything physical from us. I mean, maybe they'd want to chill out and
Yeah.
have a drink or something, right? Yeah, but
Or go to a safari, like Earth is a safari.
yeah, maybe. But
Yeah.
I think they'd want to discuss things with us. They'd have a culture, right? They'd have a culture. They'd have solved a lot of problems that we haven't solved yet, and they'd probably want to talk to the other universal explainers, uh, that most probably they've only met us up until that point. If they did get to see us, and um, that would just be extraordinary to share ideas with that
Yeah.
with that culture.
Yeah. And it's very interesting that you say that. So I'm going to spoil the book now for everybody that does not want the book to be spoiled. You can cut off the episode right now. So in the book, there's also an Ark ship, the last human survivors traveling from Earth, trying to find a different planet to live on. And they bump into the spider planet. So, but of course, conflict arises because suddenly you have two intelligent species on that planet. And you would think that there would be a big battle and so on, but that actually doesn't happen. The two intelligent species, they find common ground and they make peace with each other and they start exchanging exactly what you say, ideas, explanatory knowledge, culture, and so on. Because you also follow the development of spider culture and philosophy throughout the thousands of years in a book, and it evolves completely differently than the human ones. And in the end, they bring it together and they learn from each other and they become better as two species. And they start colonizing other parts of the galaxy by working together and exchanging their ideas. So that's how the book ends, which I think is really nice.
I like that. Yeah.
Yeah, cool.
Cool.
And on that bombshell, let's end this episode. So thanks everybody again from tuning in, from listening. And make sure to like and subscribe. And let's continue next time, next episode with the next chapter. Thanks for listening. Bye bye.
Bye, everyone. Thank you.